Hello, everybody, and welcome to Industrial Automation. It doesn't have to. In case you're new to the program, I'm Brandon Ellis. I'm your host and also the owner of elliTek. As we jump into the episode for today, I want to ask that you hit that follow button and subscribe button based upon the platform that you're listening on. And if you're listening specifically on Apple Podcasts and Spotify, and you enjoy what you hear today, leave us a 5-star rating and review. We sure would appreciate it. Now that we've got the marketing out of the way, I just want to say thanks for tuning in. So, let's get started. Hello, everybody, and welcome to Industrial Automation. It doesn't have to. I'm Brandon Ellis, your host, and with me, as always, is Miss Beth Elliott.
Hey, Brandon.
Got the sound effects down today.
You do.
Got them on lock.
You know, it seems awfully empty in here today.
Yeah, we've had quite a few guests on the last few podcasts, so it is a little bit, but it kind of comfortable too.
It is. Back to the two of us.
Got some elbow room. Well, we got some fantastic things to talk with you guys about. But kick us off, Beth. What's in the news from your perspective?
Well, we've got, let's see here. We've got a couple new partners.
New partners?
Pizzato.
So Pizzato does safety, mainly safety, industrial safety components. So door interlocks, RFID type safety interlocks. They also do push buttons. They do some fantastic e-stops that I really like because the legends are actually illuminated. They have this door handle that's fantastic. Sweet. So, your door interlocks, we do a lot of robot sales here at elliTek. And so there's the safety aspects that come with that. And so the door interlocks that they have a door handle. You can get just a door handle, but you can get a door handle that's got a tricolor LED inside that's totally programmable. Oh, that's the wrong one. I thought I had them on lock. There we go. Tricolor LED. So now all of a sudden you can change the color of the door handle itself. And this is what the operator or the team leader or the maintenance person would use to access the machine. And so if the machine's in a certain state where you can access it, maybe it's green, maybe that's a blue, maybe that's a yellow, something like that, maybe it's flashing, you can program all those things together, and it's all integrated into one M12 connector. It's really a slick deal.
It is, yeah. Those were really nice.
You saw those,
Yes, and their hinges, my goodness,
the hinges
are fancy.
They're actually load-bearing safety hinges, and they actually have the load-bearing, the larger load-bearing one actually does its own self-checking, so you can hit higher category safety without the need for secondary type systems. And so what that means is basically for all you, I'll nerd out a second here on safety. If you'll go back to our many years ago, not years ago, but a year and a half ago, industrial automation, it doesn't have to be unsafe, I believe. And we had Dave Rice of DataLogic was talking about the safety categories associated with safety line scanners and safety light curtains and stuff. And so when you got those deals, it comes down to basically self-checking. And so self-checking means that it's checking to make sure that none of the contacts, associated contacts are welded or shorted, things of that nature. And this load-bearing hinge, meaning you can hang a door on it. It's your hinge. You don't have to have a hinge and then also a safety device. It is the safety device and the hinge. And it gives what we call an OSSID output or dual channel output. So that is a higher safety category. Okay. So it's pretty interesting. The number one thing that's most interesting about Pizzato, it's in stock.
Yeah, that's true. That's a good thing.
And so that's been a great thing. So we've got a lot of customers that are really kind of trying it for the first time because they may not be as familiar with the brand. It's an Italian-made brand.
It's high quality. Very
high quality. And again, Italian-made, but stock and support here in the U.S. has been supported for quite some time, but just not as well known. But because they're stock, it makes it easier to take that chance. And nobody has had regrets. So we're pretty happy with the line.
Yeah, and our other one is Honeywell.
Honeywell products. So Honeywell, we're excited to be a Honeywell partner. And that's primarily on the handheld scanners, the fixed scanners, and the that they use for a lot of things from shipping, receiving, logistics. They're big, of course, in the retail world and things of that nature, but in the industrial manufacturing world, we use them a lot with our IT departments for IoT-based systems and things of that nature. But also they do the fixed scanners, so for conveyors, and again, that's more distribution, that kind of stuff. But also, Honeywell And this is a long discussion, past discussion where we all trying to figure out who owns who.
Okay.
But intermech printers, which are very predominant in the industrial manufacturing workplace, be it also in final pack out assembly and things of that nature, but just along the line, intermech printers are wholly owned by Honeywell, and so that's that is Honeywell as well. So if you're in our region and we can help you with any of those Honeywell products, we're happy to do that. So reach out.
Yeah, and I think we've got some training coming up too, don't we?
We have some new trainings. We've been getting asked to do a lot of trainings, and so our training center, we're bringing it back online. But it's also been difficult because we've given away a lot of our training hardware to customers who are in need because of the supply chain shortage, which we have been talking about for over a year.
Too long.
Way too long, and unfortunately, still here. We're still praying to the good Lord above that He's gonna see us through this thing, because we're all pretty much over it, right? So we've got semiconductor shortages and all this kind of stuff. So that's affected, of course, our training center, because we gotta have stuff for students to use, and so we're putting that together now. We're vamping that back up. But a couple of the new things we've got coming is we're working on a new FANUC robot maintenance programming based class, and this would be a precursor to the longer multi-day type classes if you want to go to that level. But if many of our companies, manufacturers, a lot of people use FANUC robots. So if you're using the yellow FANUC robots, and you want some training from a maintenance standpoint, we're putting together a 1-day curriculum. It might go to a 2-day, but we're going to try. But we're trying our best to keep everything mashed into 1 day. So what that means is you're not going to be bored.
That's true. It's going to be fast-paced.
It is, but we're also going to keep the class sizes very small because we want them with robots the whole time. And so still getting hold of robots is a challenge, but we do have the FANUC robots and things of that nature. And so we'll be offering those as part of our elliTek University. So feel free to go to www.ellitek.com and click on Training Center, and you can see about all of our trainings. But that's one that's going. And then also we're vamping up our more automation products training. So under that category would be PLC training, HMI training, and so of course and drives training and motion training. And so a lot of that's going to be our Siemens products. So we're putting together Siemens trainings that we'll be offering. But also we still have in the past, and we're being pressed to do so, and we want to make sure that we meet our customers where they are. And so offering some PLC-based training classes that aren't necessarily Siemens, but are very much being requested by our customer base. And so these are PLC platforms that we don't sell, we don't represent, but we are familiar with. And so we can create those curriculums and do from that. But it's the same thing. We've got to get hardware. Yeah. And so we're getting that pulled together. We certainly have Siemens hardware. So if you need Siemens hardware, give us a call. If it's part of our training center, though, I'm not going to let you have it.
That's right.
I don't know when this thing's going to be done, but we do have some Siemens hardware in stock, HMIs, PLCs, small power supplies, things of that nature. And then Siemens on the shelf has a lot of power supplies and network switches, as well as variable frequency drives. And so if that's something you're looking for, certainly let us know.
That's right.
So exciting stuff there. So I wish I could cut it off. So here, yay! We got some new products, new product partners in training.
That's right.
So take us into today's title.
All right. So today's title is Industrial IoT. It doesn't have to be misleading.
Yes, and so this is a hot topic for me.
It is.
It very much is, because marketing, I have a huge respect for marketing folks. Beth is our marketing manager and also the producer of this podcast, and so she works very hard to do that. And she does a fantastic job, but she also, I believe, is in agreement with me sometimes when I say this is a total mismarketing of a term, a product, a capability, or something. And I'm not saying it's necessarily being done on purpose. It may be a misunderstanding, but at the end of the day, it can be misleading to many of our customers. And I have a I have a very, very low tolerance for that.
Yeah, because it can cost. It can be a real price.
It can be a price, as you've got there. What's the real price? It can be a pricing nightmare. And I've touched on that in the past podcasts where we've had actual customers, our customers in our area, where we're talking to them, and they, usually it starts out about, where were you guys? Man, I wish we knew you guys 2 years ago or a year ago or something like that. And then they start to tell me the story. And the story comes down to, you just had some really good sales and marketing stuff going on. You may have had a dashboard that just looked really good.
Yeah.
And you, honestly, you're baited into hearing what you want to hear. And so many times, and that's true. We have all probably, if you've lived more than 20 years, you've probably got a situation where, I don't know, if you might have been buying a video game, a car, I don't know, sports tickets, but you heard what you wanted to hear, and then when you get there, you realize, wow, this was kind of too good to be true. It wasn't exactly
Didn't
what
meet
I
the
thought I was going to
expectations.
have.
Yeah.
And so now you're paying the price.
Yeah, and then you're kind of sour on the whole thing after that.
Yeah, exactly. and that's what we've seen also is they've just said, you know what? Management's like, yeah, they've just kind of, shaking their heads at that and said, well, yeah, we're not going down that road again. Let's get back. Some have gotten back to tick sheets and manual entry. And unfortunately, it's just today it's difficult to live like that.
Yeah.
But I'll hit you with a trivia question.
Oh, okay.
So what's the only reason, not number one, the only reason to implement an IoT system, Beth?
Oh, can I answer before it's over?
If you can do whatever you want.
It's to make educated business decisions.
Yes, educated business decisions. So if you're considering an IoT is an acronym. IoT stands for Internet of Things, and we call it IIoT, or there's Industrial IoT, or there's Industry 4.0, and then there's all kinds of other mishmashes of that. But what it means is, it's devices for industrial manufacturing. It means that we want to connect what we call smart devices, which is a PLC, a robot controller, that kind of stuff, but also it could be cameras, sensors, those kind of things. So level 2, level 3 devices, we want to connect to them to the upstairs systems. The data repositories upstairs could be hosted, which means it's on-premise. It's on your property. You own it. You manage it from a database server standpoint, or hosted, cloud-based, which means it's hosted in the cloud. Somebody else owns the server. Somebody else manages it, and you hope they take care of you.
Hope it's secure.
And then you hope it's secure. That's right. And so one you own, one you're renting. Mm-hmm. That's really, it's a lease or a buy kind of situation. And so that's what IoT is. There's a lot of things that people try to categorize it as in certain categories, and some I disagree with, and some I totally disagree with.
Okay, let's hear your BrandRant.
All right, so there are a few categories that people try to put an IoT system in and classify an IoT system and IoT hardware. Okay, so and I'm not getting into PCs and things of that nature. I mean, it's all hardware. So is an IoT system just simply something that funnels data, just grab data from here and put it there from usually the plant floor on up? Most people aren't. I don't say a lot of people don't think in terms of down. From the IT side down. Of course, we encourage our customers to go both directions to get the maximum benefit. So that means data from the plant floor devices and those smart devices up to the data repositories, or from the repositories back down to the smart devices. And so that's one classification. I agree with that. That is a fair classification of what IoT or an IoT device is and where it fits. The other classification is something that simply what we call translates or is a protocol converter. So a protocol, of course, is language. And so where it's saying, okay, this PLC can't talk directly to my database server, and so it's just, we view it as just something that's translating the language. Yes, that's possible, but that is not 100% of a classification for an IoT system. That's what we would call a protocol converter or a protocol gateway. Usually we don't use that between IT and OT. Usually that's used between, making one brand of PLC that talks one language talking to another, usually field bus languages, converting Ethernet IP to Profinet or Ethernet IP or Profinet, something like that, to a network, an Ethernet-based protocol to a serial-based protocol such as IO-Link or something like that. Those are protocol converters.
Okay.
And so we've used those for years.
Yeah.
In just the OT side of controls engineering. And so I don't really classify that as IoT, although those things can be used as part of an IoT system, especially if you've got legacy products, to bring those online to be able to get to your IoT system.
But standing alone, they're not IoT.
I don't classify that as an IoT system.
Okay.
It is a device that is... So I don't disagree with that completely. I just kind of disagree with it.
Okay.
If someone says an IoT system is a protocol converter and that's not all that it is. That's a component within an IoT system.
Okay. Did you want to go through any more of the terms?
There are. Then we get to the ones that I completely disagree with, and then the asinine. So this is the one I completely disagree with. Marketing is trying to mash in what I call remote connect. And so this is just a VPN, a secure VPN device, which allows someone on the outside, we've talked about this in some of our cybersecurity podcasts, to be able to remotely access a machine, a controller, or something like that. And it's really meant for offsite access to be able to do diagnostics or work on even programming, things of that nature. So if elliTek was the integrator or was the programmer on a machine and the customer was in, I don't know, Idaho or Hawaii or, I don't know, Chile, whatever, and somewhere far, far away, but there's network connections on both sides, and we can deploy a hardware device that allows us to do what's called a secure VPN. It can be hardware tied in with cloud or whatever. There's a lot of different flavors. And that's a remote access VPN module. That has absolutely zero to do with industrial Internet of Things. That does not let you make educated business decisions on your processes or anything. Now, you might try to use that to do a kind of quasi connection to a remote plant or remote device to pull data from it. But that's not really what it's designed to do. What it's designed to do is let someone, a person on their laptop, emulate being there beside the machine connected to it to do programming and diagnostics, and not, as a means to be a remote data acquisition system. And it's marketed that way. And I think it confuses a lot of people.
Oh, yeah.
If you need remote access, it's the way to go. I mean, it's a secure VPN if you get the right one. There's some that are less secure, but do your homework on that. But certainly it presents a security vector as far as an access, cybersecurity concern. But that's what it's for. It's not really for industrial Internet of Things.
Okay.
And now the asinine.
Yeah, I want to hear it.
A new acronym. AIoT. Artificial Intelligence of Things.
Okay.
Oh my gosh. So artificial intelligence is a thing. I mean, a term. And an Internet of Things is a term. This is a mash squash together of those two that some marketing person thought that's pretty clever.
It could be, but I think the idea of it from your perspective, from a marketer, yeah, it sounds great. But from your perspective as someone that actually uses it and does the stuff with it.
Well, there's a constant push, and we don't want to, we can do another podcast on this. If you would like, so let us know. But artificial intelligence and industrial Internet of Things can be involved. But and again, what defines artificial intelligence? This goes back to, 5, 6, 7 years ago when nobody knew what the heck IoT was. what's a thing? What's an Internet of Things? And I remember having tons of those conversations. Yeah. Well, people are going to be asking are asking now, what's artificial intelligence? What's it really mean? Because there's sensor companies, vision sensor companies, all these things. Artificial intelligence. We use artificial intelligence. Even on your websites, your CRM systems, artificial intelligence, all this kind of thing. And artificial intelligence at its base is basically the way a lot of people do it. It's just increased sample size, and so you're increasing your number of samples. So if you're talking about vision, you're taking multiple images of the same thing, and then a human is helping the system classify these are generally good and these are generally bad, and then it has to have storage for that.
Okay.
Which your Apple Watch is not going to have a huge amount of storage in it because storage takes physical space, mm-hmm. and so you just can't have terabytes and terabytes and terabytes of information on something like a yeah. You'd have to have like an Apple grandfather clock or something like that. Maybe one day in the future, but not right now. And then the same thing goes with sensors. I mean, sensors out there on the machines and things of that nature, even vision sensors, they have to have a place to store those images. And so you're increasing your sample size. And then second thing is you need processing power, more power, as Tim the Toolman Taylor used to say. And so you got to have that power because the more your sample size is, the more you have to look through.
Yeah. And
then the system from an allegorical standpoint, as far as how you would program that, way I would program that, either with case selects or if-thens for all you want to nerd out there, I would say, generally if it's if it's a no good, then we don't use that. And if it's a method or something, we don't use that anymore. We've classified that out. We just use the good methods. And then if all the good methods aren't working, we may go back. But that's the algorithm that has to be put together. But you're increasing sample size and basically saying, okay, now we use the vision sensor scenario. So if you're taking a picture of a part, the system has to be able to basically kind of looks, compare it to these bad pictures, compare it to these good pictures, and see which one it's closest to. We call that artificial intelligence. But it's not really intelligence, it's just an increased sample size.
That's where I think the miscommunication comes into play.
But there are systems out there, they're in their infancy. And this is where the Google AIs and those kind of things come together, where they start watching. They're watching and learning, mm-hmm. and what they're doing is memorizing, again, increasing sample size, but they're increasing or they're observing and taking snapshots, if you will, of tendencies. And in Google's case, and Facebook and Meta and all that kind of metaverse stuff, they're watching us. It's mm-hmm. computers watching us and trying to see and it's a programmer on the backside that's written the algorithm, but it's growing and building up this database to start figuring out and predicting what you're going to do next. And so it's predictive analysis and things that comes from that. And so that sounds great.
It does.
It sounds scary.
Yeah, I bet.
I mean, you got the I, Robot film, Will Smith on there showed us how, that could be interesting. But, we're not there yet, I don't think. But there are some systems out there that are learning like a childlike learning, but they have to have someone to teach them. And the reason I think that it's a misnomer to throw it in with IoT is just because it communicates over the network does not make it an IoT system.
Okay.
But it can be used for making some decisions, and that's the goal really of many, because we as a country, as a nation, and as a planet, my generation is working hard to make our jobs easier.
Mm-hmm.
In making our jobs easier, just like our IoT Data Commander IoT platform, which we're going to kind of be talking about, it makes things very easy. You don't have to be a programmer. It's what we would call no-code programming, mm-hmm. or no-code setup. And so it's all point and click, and all the stuff's written for you in the background, and it works very well. So from my perspective, because I know how to write protocols, how to write drivers, how to do all the programming in the background, the heavy lifting, it's a lifesaver, because I'm just like, man, this would have taken me weeks or even months before, and now I can get it done in hours. So that to me I have a lot of respect for that. I see a lot of value in it.
Uh-huh.
But if you're not a programmer and you have no concept of that, then now it becomes, I'm not going to learn that stuff. I'm just going to use this because it's easy.
Yeah.
That represents a dumbing down. And as long as IOTAs are an ample supply, there's no problem. But, in our discussion we were having earlier, I used the analogy of a matchbook. If all of a sudden all the matchbooks in the world and all the butane lighters and the means of creating fire are gone, even all the flint sticks and all that go away, and nobody knows how to rub two sticks together, then the only way we get fire is when, lightning comes out of the sky and you happen to be there, right? And so it's a dumbing down. It represents a dumbing down. And it's a dangerous balance to get into. But AI is being used a really lot, to try to basically suck the wisdom out of the brains of us old folk so that the younger folk can have an app and say, tell me what's wrong with this machine, and hold it up to it. And it listens and it sees and it watches and it says, okay, I think you need to fix this.
That's a nice thing to have, but you also need that foundation to know how to fix it yourself too, don't you think?
Well, a buddy of mine, just earlier this week, we were at a place and they were doing some games and DJ, kind of games. They had this thing called Singo, like bingo, but with the word sing.
Okay.
And he was playing music. And the titles, you had to know the titles of the songs, and you got your card, your bingo card, basically. And so we were like, this is kind of interesting. But I was looking at the titles, and I was like, man, I'm so lost. I don't see any. And I'm just not I love music, but I'm not a song title guy. Well, so the music starts playing. He grabs his phone and hits the thing, and it says listening. Boom, pops up the title, and he's like, there you go.
Yeah.
And we're just filling it out. So, am I smarter? Is he smarter? I absolutely not. We still don't know the names of most of those songs, but we were able to do it, and it's just like, you know what? I'm never going to learn the names of those songs. And that's the downfall to that. So from the people that it's just, but the person that knows all the names and studies so much and all that, it's just like, oh, wow, this makes my job so much easier. That's beneficial. That's valuable. But if I step in and I'm like, yeah, well, I can do that too, and I don't have to do all the studying and all this research that you've done. So, it's kind of one of those things.
It's a balancing act, isn't it?
That's right.
So what are, you've mentioned that there are requirements for a true edge-based MES Gateway Appliance. What are those?
So, well, first of all, let's define the edge.
Okay.
So a lot of people have asked me in an IoT system, and so enough about what is it, artificial intelligence of things. We're not talking about that.
What do we say? AIoT?
AIoT. No AIoT here. We're back to IoT. And so, and IoT has some terms that are still predominant, but edge. Mm-hmm. So you have edge-based devices, and so everybody's like, what's the edge? And it's always like the edge is pushing. And again, this comes down to marketing. And so there's also purists and that kind of stuff, I guess. There's people that say the edge is a sensor. So a sensor on the machine represents the very edge, because beyond that you can't sense anymore.
Okay.
Right? So it senses what it senses, and maybe it's temperature, maybe it's absence presence, maybe it's on or off, that kind of thing. Mm-hmm. But beyond that, that's as far as it can see. And so now we're on the edge. Some would say that's the edge. Usually we don't. We're like, yeah, that's the far, far, far edge, but you can't do a whole lot out there. So we pull it back a little bit, but still in that zip code, in that general area. So we have a device. So an edge-based device does need to be something that has some qualities to, in my opinion, brandology, in my opinion, to qualify as an edge-based device. I would call a sensor a smart device.
Okay.
And yes, it resides somewhere on the edge, as part of the edge, the far, far, far edge, whatever. But it's not really where we're doing anything. So if a sensor goes out, that certainly can affect production, but it might shut a machine down, but it's not going to mess up your projections for next year's manufacturing numbers.
Okay.
It's not going to cost you data.
Okay, even though it's collecting data?
Well, again, if its sole purpose is to collect data and it goes away, yes, it can cost you data, but it won't cost you all the data.
Okay.
So even if you lose a sensor, if you've got a decent IoT system put together, you can still, because we're Sherlock Holming a lot of stuff anyway, you can still fill in some of the blanks.
Okay.
Remember all of my many. I'm an airplane pilot, and so in an airplane you don't have one instrument; you have multiple instruments. All those are giving you feedback or data, but no one instrument's telling you everything. And so you have to look at other instruments, and then your training is if you lose one or two or some of those instruments, how can you fill in the blank? How can you ascertain what that instrument, if it was working, would be telling you as far as what the airplane's doing. And you have to kind of do that sometimes anyway. So if you have a good IoT system, just losing one sensor isn't going to be catastrophic.
Okay.
But nevertheless, so there's four qualities of it that I think qualify something as being, and this is not a one or two, this is an all.
Okay.
It needs to be reliable.
Okay.
So
we're going to go through the details on those.
Yeah, I'm
okay.
So it needs to be reliable. It needs to. I'm big on this. It needs to communicate, but I prefer it to communicate natively. We'll talk about what that means. It needs to have the ability to do data manipulation and dissemination.
Okay.
And then it needs to have data storage capabilities.
Okay.
Now, so those two things. So it's got to be reliable. It's got to be able to communicate natively, in my opinion. It needs to be able to not just manipulate data, but also disseminate data. And then it needs to be able to store data.
Okay. So reliability and dependability they can be interchangeable, but in this case, you're not talking about the durability of the product.
Right.
So what do you mean by reliability?
Well, I'm talking about, you're right, durability. When I think of durability, I'm thinking about,
how long it can last.
Yeah, just how, does it take a beating?
Yeah.
I mean, you want something that's going to take a beating to a point, but I mean, we're talking about devices here, guys. So it's not a set of tires, mud tires or anything. So yeah, not really durability, but reliability. You need to make sure that it's going to run, and so it needs to be somewhat hardened. So why did I invent the data commander? And a lot of people have asked me that question. You've heard me answer that. It's because I was doing SCADA systems at the time, and SCADA systems are still very popular. Mm-hmm. But SCADA systems are all PC based. And they were PC based when I was doing them. And so putting a SCADA system, piece of hardware SCADA out there on a PC out there, the problem was a PC is something to everybody, everything. Mm. You can use a PC to be an email machine, to be a YouTube watching machine, to be a podcast recording machine, to do a word processor, all this kind of stuff. It can be something to anybody, and that's fantastic. That's why PCs are great. It's also why they are very unreliable. From a cybersecurity standpoint, all you got to do is convince the system that you're a mouse or a smartphone or something like that. It gives you rights, and if that's the rights that you need to give you access, you can now start doing stuff, and that calls you malware. Mm-hmm. So PCs they're trying to be everything to everyone, and so in that they're not very reliable. So the reason I invented the Data Commander, which is now the IOTA, is because we needed a reliable piece of hardware. PCs are reliable to a point. Mm-hmm. Now there's questions of mean time between failure. You have industrial grade PCs, which are hardened PCs, and then you have your go down to Office Max or something, Best Buy, and get you a laptop or a PC, and that's more commercial. And so the mean time between failure on commercial systems is typically around 6 months.
Oh wow!
The mean time between failure on an industrial PC in a truly industrial environment can also be 6 to 8 months.
Oh.
It's according to how it's put in. Most of them you get a year or something like that.
Okay.
But here's the thing. It's not just mean time between failure there, but also mean time between updates. it's a Windows-based OS. Has zero to do with hardware. It's the operating system. Most everything's Windows-based. You can do, of course, Linux-based, but even Linux now is growing in popularity, and so it's now a target for cybersecurity. So it has to be updated. So the big deal is a PC is 99.9% of the time considered an asset that belongs to the IT department. Their job is to keep that and all PC-based assets up to date, and they don't get fired for not making the production, making the truck. They get fired if their PC, if there's a ransom or a virus scan or something like that. Production gets fired if they don't make the truck. So production wants to pull all the stops and get rid of all the security and all that kind of stuff, because all that does is cause problems. And that's what was happening when I was doing SCADA systems. Is about every 3 to 4 weeks when we deploy a system, once it was done, we'd be gone, and they'd call and something would happen, and inevitably it always was a virus update or Windows update or firewall update or something like that. And I've told this story before. They had a new IT administrator that they had hired, and he was given a list of acceptable softwares, the authorized softwares that are allowed to be installed on company product. But in our SCADA system software, actually it was the OPC based software, was not on the list, and he uninstalled it.
Oh my goodness!
And so he was doing his job.
Yeah.
I mean, a lot of people got mad at him, but he was doing his job, and he wasn't on the list. And so, but that's when I realized it's got to be reliable. And Windows machines are not reliable. The hardware is not reliable, but the Windows OS is great, but it's not reliable. And so, for that reason, I do not think it's an ideal edge-based device. It's a PC. Mm-hmm. And it has to always be a PC, and it has to be treated as such. And you can stick it on the edge if you want, but you're using a I don't know what's a good.
I was trying to think of something that you could use for a lot of things.
You're using a screwdriver, a hammer to drive a screw. How about that?
Okay.
It's just not. It's not what it's built for. Mm-hmm. And so from that came the Data Commander, which is an appliance. It's not a PC. It's very industrial. It's very hardened from a durability standpoint and a reliability standpoint as far as that goes. But it is dedicated. It will only ever be an MES IoT gateway appliance. Mm-hmm. It's kind of like going home and finding out your toaster oven has now decided it's a garbage disposal. It's just not going to happen.
Yeah.
But with Windows, I just listed off 5 or 6 things that it could be.
Yeah.
And so that's the difference.
Okay.
That's what I'm talking about as far as reliability. It's always going to be what you set it out to be, and it's going to do that in a safe, cyber safe, and reliable way.
Okay. Can you explain what communicating natively is and why it's beneficial?
Oh, please connect.
Is that OPC?
That's OPC. Sorry, all you OPC fans out there. I'm not a big OPC.
That's an acronym. OPC.
Oh, OPC acronym. There you go. OPC.
Oh,
please connect. It's a failure point's what it is, and because nothing, no PLCs, no CNC controllers, no robot controllers natively speak OPC.
Okay.
So the manufacturers have to create an OPC. Convert basically a protocol converter to convert their language into OPC or publish it to an OPC UA platform. It's kind of a generic language, and so everybody's always said, well, if we just support OPC, we can talk to anything. And as a result, from a cyber threat standpoint, the hackers have figured that out, that everybody has OPC UA, and so they can utilize OPC UA and OPC UA channels to try to cause problems.
Ooh.
And so just be aware of that. But it's a generic language. It's like back in the old days when with the pioneers and the Indians and that kind of stuff, they couldn't speak the native language of the Native Americans, and of course the English had their language, and so a lot of them started learning sign language, and so there was a universal sign language that many of the Indian nations accepted, so they could communicate with the English. And so if you learned that common sign language, you couldn't carry on a huge conversation, but you could maybe
you could get through.
let them know that you're not there to hurt them
Yeah.
or that you are. I don't know. But, you can communicate. So it's very limited. So in the same way, OPC, which was developed in the late 80s, it's OLE for process control.
That's
is
right,
what it
okay.
really stands for. And OLE is object linking and embedding. And it was designed by Microsoft basically to allow us to do word processing with anybody's printer using a shared driver design.
Okay.
And so it's really old, but the concept was there to build OPC, which is OLE for process control. And they've tried to remarket the acronym. I've heard some crazy stuff, but that's what it stands for, guys. That's history. Sorry, I'm an old guy. I know it. So anyway, the problem with OPC is if you speak English and I speak Japanese, and I'm not going to learn English and you're not going to learn Japanese, we both agree we're going to learn French. And now, if there's not a French word for my Japanese word, you just don't get that word.
Yeah, you're losing some data then.
And so
huh?
we certainly lose some communication
Okay.
capability. And so let's put that in a PLC world for all you PLC, all my controls people out there. Yeah. So in a PLC world, you have addresses, and that can be tag based or whatever. But whether it's timers, counters, integer tags, floating points, strings, that kind of thing, these are all out there. Well, what if you could only get to integers? Then you lose all of your analog data for all your floating points. You don't get any string data. So if you're scanning in a part number, something like that, you can't get that. So now you're going to have to stick that into an integer, and you're going to have to find a way on the other side to decrypt it and all this kind of stuff. It would be so much easier to just read the strings.
Yeah.
And so the controller companies, again, this is not just PLCs, all of them have to create software that will run on a PC environment that will read out the right stuff natively. It communicates on one side, and then it does a translation into OPC and publishes it for an OPC server to our client to pick up. And so they decide what they're going to publish.
Okay.
And if the manufacturer does not decide, you need counter values. If you need to know when your Allen Bradley timing bit is on, and they don't carry that over, you don't get it.
Oh, wow.
So you're going to have to go in and do PLC code to tie that to something that does get published to OPC, and it would just be so much easier, wouldn't it? Just to
for
say,
sure.
hey, that's the bit I want. Just tell me what that is.
Yeah.
So natively means we can get to that. We don't have to go through that other.
Okay.
Natively means even though I speak Japanese, you speak English, I learn English.
Okay.
And not just
Or I learn Japanese.
or you learn Japanese.
Okay.
But and we don't just learn a few words, we become fluent.
Yeah. Okay.
And so that's native communication.
All right.
And I think it's key for a device on the edge.
Yeah. So the third criteria you mentioned was data manipulation and dissemination. Do you want to go into more detail on that?
Yeah, I just checked the time. We're talking about a lot of stuff. I got to speed up.
Okay.
Sorry to y'all out there. Maybe press pause now and look at the other side as part 2. But data manipulation and dissemination. Yeah. So it's not. So what I mean by that? So the category that says you're just doing data translation, that means you're just taking kind of what OPC does. You're taking one native communication and you're translating it to another, or publishing it to another. An edge-based device needs to be able to do more than that. It can do that, but that doesn't need to be where it stops. It has to be able to do more. And so you need to be able to manipulate the data if needed. So grabbing raw data and publishing raw data into a database may be fine, but in a lot of cases, you may want to pull data from multiple data sources, do some analysis on it, or some math or something like that, and arrive at a more bona fide data value and publish that. And so being able to do, we call those mashups, being able to do data mashups and stuff on the edge can save a lot of time, save a lot of bandwidth, save a lot of processor speed. Because if you end up, you can end up with a math equation that's got, all kinds of arguments worth of data. And instead of having it on the upstairs side, write a program that's going to put all that together and do the math, you could just do calculate the answer and publish the answer. So sometimes, now I'm a proponent of having raw data sometimes, because sometimes you want to know where the answer came from. How do we derive that answer?
Yeah.
But there's a lot of situations where you may not need that. It's not beneficial, and you can save yourself if your edge device is able to do that. So that's where the what I call the manipulation and the dissemination. So dissemination, whether you're manipulating it or not, to be able to disseminate that across multiple platforms very efficiently. So example on that, if you got a continuous line and you want to run continuously, which means you don't want to have to clean the line completely out, all the products out from first station to the 100th station. When we're doing a changeover. Changeover means we're going to stop running part number 1. We're going to start running part number 2. Automobile 1, we're going to change from one model to the next. Mm-hmm. Well, instead of the first station having to wait until the last automobile gets off the line and we clear it all out and now we scan in all the new changeovers, we like to do that continuously so we just don't miss a beat. Well, a lot of times they need to let the downstream systems know what's coming. That can be difficult, especially if you have multiple processors, especially if they're not even the same processor brand, to get that information down. So an edge-based system should be able to manage all of that and disseminate that information straight down. So a single scan at the first station can now be disseminated down to all 100 stations, and they all know it's coming.
Okay.
And so those kind of things should be able to happen on the edge by the edge device. It should not have to go upstairs to the IT system. If the IT system goes offline, we can't do changeovers. That should not be even a possibility.
Yeah. So why we talked a little bit. You touched a little bit about the data storage, but so. Well, you want to go a little bit more into why that's so important for the edge device?
Well, being able to do the dissemination and that kind of stuff is more of an active thing. So if you scan a changeover card right now, I can disseminate that data and I'm done.
Okay.
So it's more of a real-time, here and now kind of thing.
Okay.
Data storage. So we have some customers who have all their data in some type of a cloud-based system, or maybe it's on-premise, but it's another plant on another continent somewhere. And so they've got some kind of a secure type trunk line, network going. It's not necessarily going to a Google Cloud or an AWS cloud or something like that, but it's still not there on your physical, geographic plant. And so it's tied together by some type of internet provider, an Xfinity or a Comcast or an AT&T or something like that. And the scenario is, what if the cable connection drops? Well, if everything you're doing is not just single directional and unidirectional, which means it's going from just pulling data, but you're actually pulling information down as far as your process, which a healthy IT system should do, bidirectional data pools, especially if it's involved with production. If it's doing that and all of a sudden you lose your AT&T connection, production is down.
Yeah.
So a healthy edge-based or true edge-based device should be able to ride through that. We call that ride-through. And so the way you have to do that is you have to have data storage. And so with our IoT device, we stand up a full database server on our device. We have to have memory to do that. Mm-hmm. That's not an easy thing to do. But what we can do is we can basically say, okay, because a lot of times in the cloud-based system or the hosted-based system, changes don't take place that often. Or you have your day's shift ready to go at a certain time the night before, morning of, something like that. So we can synchronize with the main server, and now all of a sudden everything's running at the edge because we have synced up our databases. If there's a change, the upstairs data service can tell us, hey, we've got a change you need to update, and we can do another synchronization at that point. But if you're doing that and all of your database is now transferred, synced up, basically an image is synced up down on the line, and now the line is running straight off of that edge-based database deal, which you could do with a PC, but remember reliability. Mm-hmm. And you've got a hardened MES Gateway Appliance, not a PC, then suddenly your downtime drops significantly. And even, of course, in our case, if you're pulling the historic data to go back upstairs, we can do our store and forward, which is a simple checkbox.
Oh, that's nice.
And if it loses the server, it just checks every 60 seconds and it'll start reloading it. It's storing it locally. And so having the capability to manage data storage efficiently and on the fly like that is key. And so we had one machine builder that their customer required them all their equipment was going outside of the U.S. And so network connections were kind of iffy where it was
sketchy.
going.
Yeah.
And so they required that it had to be able to operate without any outside communication for a month.
Oh, wow.
A 1 month ride through, and we were the only ones that could do it.
Nice.
You could do it with a PC, but they wanted no PCs on the machine.
Well, I can see why.
So
Do you have any extra bonus requirements?
Well, and this is extra bonus, and I've said it a couple of times. It needs to be cyber secure. It needs to be hardened from a cyber. And so what that means is OT-IT convergence, no. That's a marketing term. You want your OT and your IT to be able to communicate, but you do not want to converge them, because that means true convergence means whatever's on one side can see whatever's on the other side. And we can try to do this and keep this. A lot of times IT does a great job trying to do this with managed switches and VLANs and things of that nature, but it's still, those are the ways that cyber hackers are defeating right now. And so the idea is having a device like our IoT, which is a cyber hardened device. It's in the hardware design. Mm-hmm. It is not a firewall. We can see out both ports, but nothing can see through us to the other side. And getting through is very, 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 very difficult. And that is on purpose, because we want to make sure we keep those two isolated. We want to connect them with our firmware and the decisions that we're making, but we do not want to let something have the ability to bridge. You stick a PC in there, even with two network cards, and it can be bridged. It's a vulnerability or a feature, according to which side you're standing on and what your need is of the Windows OS. And so nothing is 100% secure, but there are things that are more secure than others, and ours certainly falls under a lot more secure. And so I think that maybe that's not a requirement, but man, that's a common sense thing that you would like to have.
Yeah, for sure.
And that's what separates us from our competition.
Yeah.
So we went a little long today.
Uh-oh.
Sorry about that, guys, but hopefully it's been a good topic for you. I would like to ask you one thing. We've been talking a bit about value and how much we value the people and value our audience and our listeners and some of the stuff that comes back. And I want to throw that back out at you guys. If you all value, if you get something out of what we're talking about here, right, Beth? Mm-hmm. Give us a bit of a shout out. Show us some love, but we'd love to hear your thoughts. We love hearing from folks, but I want to hear from more folks.
Yeah. For sure.
The second thing is I threw out a challenge that Beth kind of promoted about if you were going to automate something on your plant, and we were talking about specifically robotic type, with a robotic arm, SCARA, articulated arm, whatever, Cartesian system. And there was it would be simple to do if it wasn't for this one thing. What would that one thing be? We've gotten some responses, but I want to get a little more. So I'm going to throw that challenge out. We're going to keep going until we've got plenty to talk about, because I want to know what you perceive to be your biggest obstacle, and then I'm going to try to come up with a solution.
Hey, nice. I like it.
So maybe I can't, and if that's the case, we'll just all sit in the corner and cry together. But
we could find another way.
I want to come up with some, and not necessarily saying, I know all there is to know. But I've seen a lot of people smarter than me solve a lot of things. And if you have an obstacle that's similar to that, then maybe their experiences and their successes is something I can share with you.
Yeah, absolutely.
So that's the big shout out. Beth, how do you want to wrap us up?
I think we just wrap it up.
Just wrap it up. Guys, thanks for joining us today. Yes. We also always appreciate the listeners and the comments.
Absolutely.
Thanks, Beth.
Thank you, Brandon, for your expertise.
All right.
And thank you all for listening and watching.
That's right. So we got the video this time. Last time we didn't have it. Yeah. We got it square. So, now it's fall.
Yeah.
Go Vols.
Yeah, go Big Orange.
All right. We'll see you guys. Take care. Hey guys, thanks for checking out today's episode of Industrial Automation It Doesn't Have To. I hope you enjoyed it. If so, make sure you give us a rating that's pretty doggone high, and do that everywhere you listen, including Spotify and Apple Podcasts. We'd really appreciate it. Also, don't forget about our website. That's www.ellitek.com. That's ELLITEK.com. If you want to reach out to us there, you can fill out our contact form. We'd appreciate it. Also, you can email us at info@ellitech.com. And certainly for those of you that still like to dial the phone, give us a call, 865-409-1555. We'd love to hear from you.